Good evening, everyone. Welcome to COMP1531 Lecture 2. It's a fun day today. Going to be looking at Lecture 1.4, one of the more exciting lectures in the course, which is very fun. We've got 130 people here in the live streams. Very exciting. Jack's extremely astonished, as you can see. It's one big lecture tonight. I know I said yesterday that we might run overtime. I'm really optimistic that won't be the case tonight. So let's have a look. T-shirt in this weather, yeah, but you know, such a serious thing lecturing, yet really G'd up and excited. So excited to talk to you. I'm excited to talk to you tonight about JavaScript. This is kind of the only hardcore programming lecture we do in the course. In fact, week 1 is pretty much just like, let's teach you Git, let's teach you all of Git, let's teach you all of JavaScript and just get it out of the way. And like we keep talking about it, but when we used to run this course, it used to kind of be very, you know, we do little bits everywhere, but again, this is the 6th time I've run this course and I'm becoming more confident that it's better just to kind of go bam in week 1 and do it. So we're going to have some fun tonight. For those of you who struggled a little bit with Git last night, you're probably going to have a bit more fun today because you're probably used to programming. You're probably going to have a bit of fun with programming. So let's go and have a look at that. Now, lecture 1.4, JavaScript. In this lecture, so JavaScript is a valuable tool to learn and it's necessary for the project, right? It's a programming language. It helps solve problems. It is not special. You know, I'm not in love with it. Neither should you. You shouldn't be in love with any programming language. But it is a valuable tool for what we're trying to achieve, and it's also very, 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 very common in the software engineering space, which is why it's so useful to talk about. Tonight we'll be talking about learning a second language, comparing it to C, because if you're doing this course, you should know C. If you don't know C, I'm a little confused how you got here, but that's okay. We still like you. And then thirdly, what are the core JavaScript language features, which takes up most of this lecture? So big disclaimer first. Because you already know C, we will teach you JavaScript very quickly and mainly focus on the differences between them and the new features. Unlike C, JavaScript has a sprawling set of capabilities. And what that means is that C, whilst it is a difficult language to program in, the language syntax itself is actually really simple. You could write it all down on a piece of paper. It's one of the only languages like that. Most other languages out there, you know, from Java to Python to JavaScript to C++ to C# to Ruby, they all have quite a lot of... There's a lot you can learn. It feels like it takes you a long, long, long time to learn all the odds and ends of the language. But if you've done 1511 or 1911, you kind of know everything about C. Maybe you just can't do a lot with it. But so please don't think it's like C where it's like you learn 10 or 12 things and you know everything. It's going to feel like you finish this course still not knowing a lot about these programming languages like JavaScript. And that's totally okay. YK says, which is more useful in the software engineering industry, Python or JavaScript? I don't want to answer that question with authority because I'm just an idiot talking to you. What I will tell you without going very neck deep into it is that if you're trying to build full stack web-based applications quickly and safely, I very rarely seen situations where Python is used in industry much. Often JavaScript. And if you spend more time with the language, you'll start to understand why eventually. You know, when I started my company in 2018, I actually was doing a lot of Python at the time. And I hired a couple of people like casually, and I wanted to use Python. And they were like, no, that's a bad idea. And I was like, oh, does it really matter? And we use JavaScript, and I understand now why they were doing that. So just kind of, you know, if you end up in industry, you're probably going to be doing JavaScript more than Python. But it doesn't matter. It's not a pissing contest, right? Like, You can point to 100 different things about every single programming language that suck. I can point to a bunch of things I hate about Python, things I hate about C, things I hate about C++, things I hate about JavaScript. Doesn't matter, right? There's a great quote. I need to remember who said it, but let me just look it up. What is it? It's like... they say, what is it? There are two types of programming languages, those that people complain about and those that people don't use. I'm pretty sure it's like that or something. Anyways, point is that, you know, people like to sit around being blah, 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 what language is good, what language is bad, but like they're all fine, except Java. Just kidding. But not really. Java's kind of crap, but let's not go there. Java's okay. I'm not going to get into this. Java held up the world for a long time. We should love it and respect it. Okay, so JavaScript. JavaScript is a high-level, multi-paradigm scripting language with a massive popularity in the web-based software engineering space. That's a big lot of words. Let's unpack that really quickly. So high-level means that unlike C, you're not dealing with pointers and memory and other complicated things. Multi-paradigm means it touches on a few different areas like functional program, object-oriented programming, imperative programming, which many of you hear those three words and you think, great. Basically, C is a type of programming language. JavaScript touches on a few different types at the same time. A lot of languages kind of touch on a few different types at the same time. Though JavaScript has become the universal go-to language to build web-based applications, which is becoming more and more the way that we build end-user applications. Because remember, most software engineering is about writing software for people, and most software that we write for people these days happens on the internet, and most software that we write on the internet happens with JavaScript. So that's the background of the language. Here is some example JavaScript. This is a program that declares a variable a, makes it 3, and then it creates a function called hello, and I don't know why that code's there. By the way, all the code in all the lectures is like rewritten this term, so occasionally you're going to find something that is just kind of a bit weird. And we've kind of seen that here, but let's gloss over it because this isn't meant to be code that runs. This is just kind of showing you, it kind of looks like code, right? You know, there's a few differences. This word function here, normally you have int or void from C. The braces are similar. I don't know what these backticks or the $sign is. That's kind of weird. We've got semicolons. I don't know what const is. Is that a data type? So this is just here to show you that, okay, it's sort of similar to what you might be used to, but it is also a little bit different. And what we're going to be talking about are the differences. So why JavaScript? I know I've kind of touched on this a little bit, but JavaScript has one of the most rich open source library and package manager sets of tools. Basically, it's really designed to build applications quickly, and it has probably the highest level of support out there. It's high level like Python and other languages, which makes it much quicker to write code. That'll be clear to you tonight. It's well supported in industry, and I've mentioned this about webs and web-based stuff and everything else. Okay, so learning another language. Learning another programming language is actually relatively easy. And if anyone out there has gone and learned different languages, you'll know that if you know German and you want to learn Dutch, or you know English and you want to learn French, that is a much easier transition than if you know English and you're trying to learn Arabic, or if you know English and you're trying to learn Mandarin or Cantonese, right? And similarly, programming languages, just like human languages, but in a very different way, aren't just all unique, like equally different. Some of them can be kind of grouped together because they have very similar properties. JavaScript looks a little bit like C here in some ways. There are other languages that don't look anything like C. So C is a procedural language. That means that it runs from the top to the bottom. It's also a typed language. It has types and it also has pointers, and you also compile it with a program like GCC. I know this slide is slightly... Let me make some notes of this. Again, these are all totally new lecture slides, so occasionally I just will notice some problems. That's what C is. It's not an object-oriented language, whatever that means. You'll learn about object-oriented languages in COMP1531, which you can do after this course. And there's a few different languages here, but then we have JavaScript at the bottom. JavaScript is a procedural language, so we can write JavaScript just like we write C. It can be an object-oriented language, though we're not going to do much of that in this course, probably none of it. It can be a typed language as well, as in we can use types like in C, how we have ints and doubles and chars. It's kind of optional, and we get to that in week 3. We're not going to be talking about that today. But it doesn't have access to pointers, and it's not a compiled programming language. It doesn't have an equivalent for GCC. Lita asks a really great question. Oh yeah, C++ has pointers. That's an actual typo. Thank you. So Lita asks a really good question, which is what determines if a language is typed or compiled or not? Is it just whether the creator of a language felt like using it? Yeah, pretty much. So people write languages. Big communities of people get together and write a language, sometimes just one person. They go and write a language definition and they decide what's happening with it, and then people go out there and write compilers, and then people start writing code with it. It's really that simple. So, you know, these are just different because different people created them and they had different ideas and they had things they wanted to solve, and these all have pros and cons. But the point is that they're different, and my main thing I'm trying to emphasize is that JavaScript, like C, is procedural. The typing is optional, ints, doubles, and chars, and also it doesn't have pointers and it's not compiled, which we'll touch on in a second. This is a summary of what I've just mentioned. Doesn't have pointers, it's higher level. That's literally a summary of what I've just mentioned, so let's move on from that. But let's get into the differences between them, right? And we'll talk about the compilation element, we'll talk about the types and everything else. On the left here, you see a piece of C programming, right? It looks like C. I've got a function called minimum, takes in 2 ints, it checks which one's bigger, and it returns one of them depending on whether it's bigger or not. The function also returns an int, which is why it has int out here. JavaScript, you'll notice, is very similar. By the way, all the code here, you can actually just go and click on the link and it'll open up the page, so you can actually just go and get the code anytime. Just look up in the lecture slides. JavaScript is very similar, and the only difference you'll notice in this really simple example that's trying to create a minimum function is that there are no types. So the parameters A and B don't need to be specified as int, and you don't need a return type, but the way the JavaScript language works is that all functions need to start with the word function. That's how we're going to start. If you're really smart and you've done this stuff before, I will say things that are mostly true, so please don't feel obliged to correct me, because other people will discover that things I say are mostly true naturally. Like, we don't need to conflate everything really early on. It's just kind of a lot. So very, very simple. The keyword function's necessary, there's no types. This doesn't mean that JavaScript necessarily doesn't have types, because types are kind of just baked into a computer in a sense that computer programs need to have an idea of what a type is. Something needs to have it needs to have classification to work on a computer. It's more just that JavaScript figures out types for you. So JavaScript doesn't need you to tell it what the types are. JavaScript will figure out those types. Right? So watch now we'll have a look at a bit more of a difference between the language. So let's say we write these two functions in C and JavaScript, and now we want to call them. We want to call them respectively and print out the results. This is how we would do it differently. In C, you've got your int main, int char star, int argc, char star, argv, array, kind of thing like this. And then you have your printf with your format string, %d, new line, and then you call the minimum function like this. In JavaScript, though, you simply call console, which means terminal, like the terminal on your computer, .log minimum 3,5. So you can already see that the language is starting to be a little bit simpler. You don't need a main function or anything like that. The interpreter for JavaScript, the thing that runs the JavaScript, will just run the code as it is. It doesn't need kind of this babying. It'll automatically put a new line at the end. You don't need to put a /n there. And the console log function's a little bit more dynamic than the printf in terms of you can just give it something and it will just print it. So it's a little bit simpler there. How do we run this, though? Is a question I see come up a little bit in the chat, right? How do we actually run this code? Well, let's have a look. With C, you have to do this whole gcc-wall-where-o, and I know in 1511 these days you use a lot of DCC, which is kind of like GCC for, you know, newbies. With C, you have an explicit compilation step. And this step here converts your source code into machine code, and then you run that machine code. Right, and just for a recap, because I understand that there are some of you here who might not have, used C for a long time. Let's imagine that I have this C file here. I'll call it code.c. And I'll just save it here. I can take this command. I know that it's called something else here, and I know my head's in the way. And this, let me move this thing. There we go. I've got code.c here, and I want to output it to runnable, except I need to... Oops. Oh no. Hope that works. Yep, okay. There's a typo on that slide too. That other -o shouldn't be there. I'll get rid of that one. So basically, I've had to do two steps here, and that first step produces this runnable file, and this file is machine code. Whereas with JavaScript, what it actually does is it actually kind of compiles and runs the code at the same time. So there's no intermediate step. So if I was to say, come and take this code here, this JavaScript code, and create like a code.js, because that's the file for JavaScript, to run that, instead of using GCC, I can actually just run node. We'll come back to what node is in a second. And I can just run node code.js, and it will run the code, and it will console log that to the terminal. So much simpler. And it's not that when we say is it compiled, what we really mean is there an explicit compilation step? All code has to... I hope I'm right. Anyway, all code has to be compiled, but some programming languages like JavaScript compile and run it at the same time. And that actually makes it slower. So JavaScript is slower than languages that are explicitly compiled, but it is much easier to work with because you don't have to kind of break everything up into a couple of steps. It doesn't have to like compile the whole code together to run it. So it's kind of like quicker to develop with, generally quicker to develop, generally slower to run, right? And you can start to actually understand that in the real world, sometimes languages that are easier to write code in but maybe aren't as quick are actually a good thing, right? We'll talk more about that as we go. I also have a question here from Jen, who says, can you explain argc and argv? We haven't really touched that in 1511. I don't know what they teach in 1511 anymore. I know they've been slowly cutting content out, so if they have cut that out, then disregard it, because we don't deal with that really in the course much. So you don't need to worry about that. I just put that there because I was assuming that was still part of the course, but it might not be. And some of you might have seen it. I'm not sure. But anyway, back to this. Okay, but what is node? Because I just ran this with this command node here. Have you seen that before? Node? Well, what this is, I've already talked about the steps missing, right? Because there aren't steps missing, because the compilation and the running is the same. But let's talk about node for a second. So Node.js is a command line interface. What that means is it's a program you run on the command line, just like Git, just like GCC, just like gedit, just like Nano, all these other programs. It is a command line interface that interprets JavaScript code and then runs it. That's it. Node.js is the program that compiles and runs JavaScript, right? It's similar to GCC if GCC then immediately ran the code. So it is the program, it is the compiler for JavaScript. Though you wouldn't call it a compiler, you call it an interpreter, because it's not actually just like compiling the code to machine code, it's interpreting it and running it. I'm not going to go into 6 feet of what all of that means right now, because we're 147 minutes into the course, right? We can relax. I've touched on this a little bit, but Node.js is interpreted. I mentioned that it combines them together, and as I said before, it's more convenient and a little bit slower. I've touched on this already. Some of the slides are here because I know people want to read back through the slides, so Don't be stressed if I touch on things early or not. The slides are mostly here just for you. I could just talk for 2 hours to a blank screen, but not everyone wants to watch a video of me just talking, right? Sometimes it's good to flick through some slides. Okay. So we've talked about Node. We've talked about JavaScript. Brendan says, so I assume Node is akin to the Python interpreter, and as such, NPM is akin to pip. Yes, I know some of you are familiar with Python, and yes, that is true. If you aren't familiar with Python, you don't need to worry about that then too. Okay. We're just going to literally speed run the language. I don't want to call it a speed one. We're going to speed power walk. We're going to speed power walk JavaScript because you know how to program. You know how to do if statements and while loops and variables and functions. We just need to kind of show you what's different about JavaScript. So let's first have a look at this big chunk of code. Now I forgot to kind of get my code up locally for this lecture, so we'll do that next lecture. But first thing you'll see here, comments, just like C, /, totally normal, as you'd expect. Variable declarations and definitions, though, in JavaScript are a little bit different. And what I mean by that is in JavaScript, because variables aren't strictly typed, because you don't type them yourself, you don't actually need to say whether it's an int or not. JavaScript will figure it out. So if I just kind of say get rid of all this code at the bottom for a second, we've got our const years equals 5, and I can console log years like this. This code will run. Const simply means that it can't be modified after it's declared. So if I say years equals 6 now, it won't work. The other way I can declare a variable is with let. So let and const are the two keywords that you put before a new variable. And if you make something let, it's just a variable that can be modified. So it's just let and const, like this. Right? That's it. And the interpreter is quite helpful. It says assignment to constant variable. It's like, no, don't do that. JavaScript determines the type for you. And I'll show you. There's actually a JavaScript thing that you don't have to worry about, but I'll just show you, which is is it instance of? What is it? Oh god, I think I'm thinking of Python. I think it's type of. So you don't have to do this, but I'll show you anyway. In JavaScript, I can actually check what JavaScript thinks the type of a variable is. And you'll see here it thinks it's a number, but if I change this to a string, JavaScript is smart enough to kind of interpret that. So it's not that JavaScript doesn't have types. It does have simpler types than C, but most importantly, it just figures that out for you. So that's kind of the really basics of const and let. Now, all these other variables here declared with const, JavaScript figures out whether they're strings or whether they're numbers, or whether they're numbers. It kind of treats integers and floats and stuff the same. And then it has two other types, which are, I don't want to call them similar to C's null, because we all know there's null in C. Null is a pointer to the address 0. In JavaScript, there is no null because we don't deal with pointers, but there is no like C-style null. But there are two particular values which are undefined and null. Both of these are not... it's a little bit annoying that the language has both of these, but they're both ways of saying nothing. Right? So they're kind of a way of saying, you know what, if I want to give someone an age, but I want to describe that the age hasn't been set or that it doesn't exist, null and undefined are kind of two values in the language that can be used to express nothing. We don't really care what you use, but generally speaking, null is there to represent that it's like it's something but it's nothing, and undefined is there to represent that it's not anything, which I know sounds like a weird philosophical thing, but that's probably how they're most commonly used, but honestly, people would have different opinions. The only important thing is that you don't use them interchangeably. So if you want to kind of express nothing in your code, pick undefined or pick null. Don't pick both. But you can kind of do either, but just don't pick both because they're not the same, even though they kind of might mean similar things. You can see that we can console log variables out, and we can also console log strings. So if I run this code now, got to save it. If I run this code now, I print 5, I print giraffe, I print 2048.11, I print hello, I print how are you. Right, all relatively straightforward stuff. Leader asks a question about CommonJS and ES6 beyond the scope of the course, so I'm not going to address it. Petru says, is there a difference between let and var? It's a good question, but I'm not going to answer it in detail. On the internet, you will actually see often that there is a third type of variable. Instead of const and let, you'll actually see one called var. Don't use var. It's an old thing. It has some pitfalls. You'll see it online, but just use const or let. If you see var, just use let. Right? I'm not going to go into what that is again. We're so early in the course, and it's not about every particular part of Python. Sorry, not of Python. I've done this course so much in Python, I keep saying Python. If I ever say Python, I just mean JavaScript. Is there a style guide for COMP1531? That's a great question from Alex. Let me have a look. Did we give you one? We might have gotten rid of it. But we do introduce a style guide in week 3. Before then, we don't have an explicit style guide, and I think that that's okay, because for the first couple of weeks of the course, we're happy for you just to settle in and just kind of do things naturally. Unlike, like all languages, there is no best way to write code. There are just different opinions. So maybe talk with your group when you start writing code about how you want to write code, but generally speaking, we're pretty relaxed for the first couple of weeks. You're not going to lose any marks or anything because of how your code looks to start off with. Okay, moving on. Strings. Strings are an interesting topic in JavaScript because they are slightly different to C. C strings are really, really, really simple, whereas JavaScript strings, frankly, just like strings in many other languages, are a bit more involved. So if we have a look at some examples here, first thing, I'm going to let the variable sentence be equal to the string my. One of the first things you'll notice is that I am able to then actually redefine that kind of similar to how you do in C with a number, right? Like in C, you can say I equals 1, I equals I plus 1. But in JavaScript, you can do those same kind of seemingly mathematical operations, but with strings. And the way it works in JavaScript with strings is that it actually joins them together. So when you add two strings together in JavaScript, it actually just connects them together. We call that concatenation. And similarly, you can do just like you do mathematically with numbers, things like plus equals. Because remember, with C, if you say, int I equals 1, and then you say I plus equals 2, you're just adding 2 to 1. So similarly here, if I just add Pikachu to the sentence, I'm actually just combining it. And I'll actually use some comments. The comments, again, in JavaScript are just like C. So let's actually run this code, and you'll see that it goes my, it adds name is, and then it adds Pikachu. So it all just gets joined together very naturally. It's a very easy thing to work with. So if C-style strings ever really hurt your soul and made you sad, you will have a bit more fun here. The other thing to do with strings is that you can form complex strings quite easily in JavaScript. So I have an age here that's 7 and a name that is Hayden. However, on this line 11 here, if I would like to create a complicated string, where in that string, I'm just trying to expand this window slightly. Give me a sec. Where in that string, I want to be able to say something like, hello, my name is a thing, and I am a thing. I can actually do this, where if I go and put a variable, or any kind of like mathematics or variables, inside braces with a dollar out the front, and then I put that inside these back quotes here, it will actually it will kind of figure it all out for me. It'll shove it in, and you'll see this here. If I do that, you look at the second line, it says, hello, my name is Hayden and I am 7, like that. And that's very useful. Now, these back ticks, they're often at the top left of your keyboard. Above the tab is a common place you'll see them. you'll notice what happens if I just use single quotes, it won't work. It'll print it out literally. We call this a literal string because it will just print out the characters as you describe them. And also in JavaScript, you can use both double and single quotes for strings. You might have kind of noticed that already because in C, everything you do is, well, not everything, nearly everything you do is double apostrophes. But in JavaScript, it can be either. They are generally interchangeable. I like single quotes. Don't know why. Completely baseless. I'll do whatever the style guide tells me to do. Though if you want to kind of do this interpolation thing, you need to use the backticks like that. That's what tells JavaScript to actually look for these dollar symbols and braces. Otherwise, it'll just kind of ignore them. So that's a cool little thing. Great. Control structures in JavaScript. Control structures are if statements, else statements, loops. This is also relative. Sorry, I clicked a button. This is also relatively manageable. Here, I've got a variable called 5. If number is greater than 10, console log, else if, do that, else this. This is kind of identical to C, really. Like, the type thing of number and the console log is different, but like, functionally, it's very similar to C. If, else, just as you'd expect. While loops are also pretty much identical to C. For loops can be pretty much identical to C. We'll talk about those in more detail as we go on. I know there's a bunch of smarty pants in here that know all these kind of like fancy things about, you know, what you can do with JavaScript, but so I'm just taking another few notes. If I don't take notes now, I'll completely forget after the lecture. Switch statements. That's a good question. James has come in and said, switch statements. Switch statements do exist, but I'll be perfectly honest with you. I don't think I've ever written a switch statement in JavaScript, and I first used JavaScript a long time ago, probably like 13 years ago now. Yeah, I don't know. I mean, it exists. I just don't use it. I'm sure you can Google it, and it will look pretty similar. So, pretty easy. Now, that's it. Like, this is one of the advantages of JavaScript is that it is at a simple level. It's really similar to C. Generally, you don't really use while loops in C either because for loops are quite clean. I don't know if they teach you for loops in 1.5.1.1. I think they do these days. So that's good. Leaders asked a question that I might jump to just because I finished this slide, which is there a place on WebCMS 3 that states what we are learning each week? Yeah, under the coursework, there's the lectures. There's the timetable, which is all about timing of things. And then there is the coursework, which is all about the things you do. So you can kind of go and look at this. You can look, I've put all this up. Like, I got this all organized before the term. You can go and look at everything. It's all right here. The whole course is already given to you. So go check that out anytime. Okay, they don't teach for loops in 1.5.1.1. Oh, okay. Well, for those who don't know it, for loops are reorganized while loops. In fact, they're such a straightforward concept to get. I know many of you would know them because if you weren't taught them, you would have just figured it out yourself. But just for your own understanding, for loops quite literally take this part and shove it here, and then they take this part and they shove it here, and then they take this part and they shove it here, and that's it. That's for loops. That's it. It's just syntactic rearrangement to make things a little bit cleaner. Nothing special about it, and it just uses semicolons to separate those three different properties. That's why they're popular, because most while loops are really doing the same thing. They're all setting up, they're all looping whilst a condition is true, and then they're all doing some kind of action every loop, which is typically an increment of some kind. So That's for loops, while loops in a nutshell. Okay, JavaScript functions. We kind of already touched on this, so not much to add. Just the word function, no numbers, no types, sorry, not numbers. All of your functions should start with function and then the name. So function and then the name of the function. So really, really easy. Nothing to add there. And that's kind of the basics of the language. We talked a lot about JavaScript as opposed to Python before the course when it came to the transition. And there are some definite downsides of JavaScript. But one of the upsides is that it's actually kind of similar to C. Which is great because this lecture is a lot more peaceful than it used to be because the syntax, for better or worse, is similar to C. It's very easy for you with your C brains to just kind of be like, just understand it. And to Daniel's question, no return type either. Yeah, so just like there's no parameter types, there's no return type. JavaScript will figure that out for you. Okay, moving on to a little bit of theory. So we're going to talk about some data structures in JavaScript. Sorry, brain turned off. But before we talk about data structures in JavaScript, we're going to talk about the theory of data structures. That's fun. It's really fun. And this is just really important. I don't think this is really taught anywhere in a core course as much. So I might have introduced it into 2521. I don't really know, depending on whether they've used some of my stuff or not. But this used to be in C++, and I really liked the language. So when it comes to your data structures that you deal with, typically we call collections the set of data structures that are just about collecting data. If you've done 1511 or 1911, you are familiar typically with definitely arrays as a data structure, as a collection of stuff, structs as a collection of stuff, and if you did 1511, linked lists. And these are all collections. They're all different ways of storing collections of things. Two important types of data structures, like two different ways of categorizing data structures are either sequential collections or associative collections. Now, in a nutshell, sequential collections are arrays and linked lists. Associative collections are structs. And this is kind of important to think about academically before we look at the code. Sequential collections are exactly what you'd expect, and you know this from C. In C, you have arrays. In JavaScript, you have arrays. Arrays are a collection of similar type components. Oh, good. If Sasha's been talking about it now, then that's good. Sasha's very theoretically minded, which is great. So I'm really glad if she's talking about it now. Good recap then. So in JavaScript, we've got these sequential containers, collections, and one of the subtle things is that in C, you might be used to having arrays and linked lists as two separate data structures with pros and cons. And in fact, if you've done 2521, you definitely know about these. In JavaScript, though, an array is both arrays and linked lists. It's basically if you have an ordered sequential collection of data, you use a JavaScript array. So there's just like the sequential data type in JavaScript, which we call an array. Associated, it's a typo, associative containers, though, are where, and this is a bit trickier, these are more like structs in C. And they are where values are referenced by their string key that maps to a value. So again, if you've learned this a bit more in 1511, great, it's a bit of a recap. They often do not have an inherent sense of order. That's why they're not called sequential containers, sequential collections, containers, whatever. They are called associative containers because they don't have order. They're not in a sequence. It's just that all the values are associated with what we typically call a key. And you know this again from C because if you've ever made a struct in C, like struct person, and that, has like a char star name and an int age and, a char star city, you've created an associative collection here where you have three pieces of data that don't have a specific order, but each of those three pieces of data are identified by the fact that there's a key that identifies them, i.e. the key name tells you the name of the person. The key age gets you the value of the age of the person, right? The key city gets you the city they live in. And all of that. So that's the nutshell of these associative and sequential items. Now, onto a few more practical elements. arrays, I don't know why it's a lemon. Half the emojis in this just, so if I didn't know, I just made something up. Arrays in JavaScript are very straightforward. They're very much like C, but in a lot of ways they're kind of simplified. They are mutable, ordered structures, and what that means, mutable means that they can be changed, as in when you create them, you can go and change them later. You can do that in C too. They are ordered like C, which means they're sequential. They have a sense of order. And they typically contain data of the same type. Now, in JavaScript, unlike C, your arrays can actually consist of like strings and numbers if you really want them to, but don't do that because you're a bad person. I don't know. I'm just trying to double check. I hate saying blanket statements because, you know, anyone who makes blanket statements that confidently is kind of an a-hole, right? But it's like, I can't think of a good situation where I'd ever have an array, a single array that contains two data types in it. It just sounds like messy code. So it's possible, but don't do it. You should already understand arrays from 1511. However, let's look at how we can use them in JavaScript. So firstly, let's copy this code and take a look. We'll go and inspect it, play around with it. So we've got our array up here. You know, this looks very C-like again. Again, benefit of JavaScript is we don't have to deal with malloc or any weird stuff for strings. We can just describe them like this. What I've then said here is the first thing I've done is I've gone and console logged. Oops, can't remember. What's the command? It's the shortcut to comment. It doesn't matter. I've gone and console logged 1 and then names, and that's given me 1, Hayden, Jake, Nick, Emily. So one cool thing is if we just print out the array, JavaScript is smart enough to just concatenate everything, join it together, and then just give it to us. So really, really easy to debug. You don't have to for loop it or anything. I can go and get the first element of the array, like this. I can go and get Hayden, like that. I can also modify the array. So if I would like to change the element at index 1, which is Jake, I can go and change that to Jaco. And then if I'd like to add something to the end of the array, I can just do the array dot push Rennie, like this. And then I can just print out the new array. And now it'll say Hayden, Jaco, Nick, Emily, Rennie. Bam. Really, really easy to modify, right? Really easy to modify. So the arrays aren't a fixed size. Unlike C, they can be any size. They can be dynamically sized. JavaScript will just figure it out for you. It will just keep it. So like the way JavaScript works is it will kind of quietly malloc things in the background for you, right? It will just like, if you just keep adding more, like, so I think that's maybe an important thing to touch on very briefly. So in JavaScript, things are malloced like in C. It's just that JavaScript does that for you. Under the hood, most things are the same in computing. It's just a question of what you do, right? So when you create this array here, JavaScript will actually malloc something for you. And if you push enough things to it, it will actually go and malloc another one and then copy stuff and do all that. Is it? Ah, thank you guys. Whoever said that. So most of this should make sense. The 2 points, and someone's touched on this, right? Oh, and so firstly, Daniel has a good question. Daniel says, does that mean that there's no guarantee that array indices are contiguous in memory? I don't know. So in C, you kind of have a guarantee that if you have an array, which is a bunch of boxes, all those boxes are right next to each other, you know? That helps with some performance things. I don't know about JavaScript. I'd imagine that it must still be true. I don't know, but I guess a bigger point is in JavaScript, because you're dealing with a higher level language, you're not trying to chase that level of performance. And therefore, it's like, even if it was contiguous, it's not... If you're using JavaScript, you're probably not going to be thinking about that kind of stuff as much. Though it's a great question, and I just don't know the answer off the top of my head. So to address the next one, which was asked, I'm just trying to find it in my... I can't see it in my little chat, but someone has asked a question here, which is, Vanch has said, don't we need to use let instead of const to modify things? Oh, there it is. And Vanch is right onto it. So Vanch is like, okay, I'm really confused now. You said we use let when we're going to change stuff, but const when we can't change it. But you've just made this array const, but then you've just gone to change the array. You've literally changed an element of it, and you've literally added something to it. So some of this gets into object theory, which we'll talk about in a moment. Probably after the break. We'll have a break soon. But what I will quickly explain to you is that when we have a variable like names, this points to an array, and that array is a data structure, and that array is this. When I say points, I mean don't overthink that with pointers. It's like names is just that array. What the const means is that names is always this array. It can't be another array. So where this code would fail is if I said names equals another array, because now I'm kind of telling it that it's another array, and then it would fail. But what's actually happening is it's always the same array. It's just that what's inside of the array is like changing and stuff, you know. So all the kind of modifications are happening kind of in that bubble. So names is a bubble, which is an array, and the magic happens in that bubble. It's a little bit weird, but it kind of makes sense. But it's a great question to ask. It shows that you're kind of really thinking about the language and the semantic. Semantic, by the way, is a word that describes, it's the meaning of words. So it's a word that means the meaning of words. It should be used a lot in programming because, you know, you would say that push has a clear semantic. It's saying that we're going to push to the array. Folway says, so if I use let, name can be redefined. Exactly. So if I use let here, I can say names equals new array, and that will work. Some of you might have also noticed JavaScript's actually a very kind language. If I skip semicolons and stuff, it will usually figure it out. So don't stress if like you think your code should be breaking, but it's not. Sometimes JavaScript will just like be nice to you. And it, like, if it's kind of like that should probably be a semicolon, it'll just kind of put it in for you. Not like put it in, but it'll understand that it should be there sometimes. Don't do that though. Don't rely on that, but that's just an important note. There was also another great question from someone which says, sorry, I've lost it again. It was to do with looping. G. Where's G? G said, so I don't know why it doesn't appear in my little tools sometimes. But anyway, G said, what about looping through an array? Looping through an array is exactly like C. So if I got all these items here and I want to loop through the array, I can do something like this. I can say, you know, for let I equals 0. I can then say, we do some examples of this later, so I'm just jumping on it early. I can actually do this here. I can actually do names.length. It's a little bit weird. It's a little bit weird that you can do this, and again, we'll talk about what that is in a moment. But I can loop through arrays relatively easily, and I can say, you know, console log name I plus 1 is names I, right? And then when I run that, it will print it out. Name 1 is Hayden, name 2 is Jaco, name 3 is Nick, name 4 is Emily, name 5 is Rennie. Like that. So I can use that loop there just like you'd expect. The only difference beyond things we've learned so far is that you don't need to hard code the size of the array. JavaScript actually kind of keeps track of that for you, so you don't need to keep track of the size. Names.length is a value. If names.length and names.push is confusing, let's talk about it in about 10 or 15 minutes because it'll make a bit more sense when we talk about objects. There's more looping. I should have just waited a second. Oh, we got a few loops. Okay, we'll get through these, then we'll have a break. Sorry, there's a couple more examples. Foti has asked a great question, which is, do we need to do things in JavaScript like hash include hash include stuff from C? So the answer is, so in C, you have like hash includes.ao.h. The short answer is yes, you do. The more complicated answer is, whilst you do, you don't need to do it as much, and therefore we actually don't include it in the first week. So you don't actually need to do any kind of including in the first week. That's like a week 2 topic, and we do that just to make the first week really, really easy. Okay. So some more stuff with looping. I don't know if I need to run this code as much because I kind of just showed you this, right? We have 5 items. We can while loop through them. We can for loop through them. And then I just showed you this is the same for loop, except that instead of 5, we actually just use the length. And we'll talk about this magical length thing later. But you can just use this pretty normally like that. Here is a bit more of an involved piece of code that kind of shows off a bit of a function and a bit of an array. And this is that we have a function here called getEvens. And getEvens takes in an array. It actually takes in a whole array. Now why this might be interesting, of course, is that this language doesn't have pointers like C. So when I actually run my code down here, you can kind of imagine that this is kind of like my main code. I go and create my all numbers array, which has 10 items in it. And then I console log the result of calling getEvens with all numbers. So I call getEvens with all numbers just like that. Now, getEvens is a function that I would really like to go and get me all the even numbers in that array. I could create a really dumb version of this function that simply just returns nums. So the function does nothing. It just returns exactly what I give it. So this is a dumb function. However, immediately, even before we write or look at the code for this, you'll notice that unlike C, I don't have to go and use pointers. I can just pass an array like I would pass a number or a string, and it just does it. It just handles it exactly like you'd expect, which is really handy. You don't have to worry about any of that pass by reference, pass by value, point to this, point to that. You're just giving it the array. Now, you are not giving it a copy of the array. You are giving it the real array. Everything in JavaScript kind of implicitly does everything like by pointer, but that's mostly what you want a lot of the time. So what you can see here is that inside my getEvens function, I'm going to create a new empty array called evens. Then I'm going to loop through, give me one second. So I'm going to loop through sorry, give me literally 1 sec, something's just happening. Sorry. Anyway, so you can see here that I'm just going to loop through every single nums here. I'm going to go from 0 all the way through the end. So I'm going through 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to the end. Right? Something didn't break with the code, but that's okay. Now what I'm going to do is for each number I loop through, I'm going to check, is that number mod 2 equal to 0, i.e. is it an even number? If I divide it by 2, is the remainder 0? And then if it is, I'm going to push that number to my new array. So I'm kind of like going through each item in my old array, and if it's even, I'm kind of adding it to my new array. So you imagine if you have, I can probably just screenshot this. If you have like all these numbers here, right, like this, I'm just kind of going through, and if it's even, I'm just like dragging it down to my new array. So I'm going tick, 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 dragging them all down just like that. And therefore my new array is formed just by those 5 numbers, like this. And I push it one by one, and then I return that new array, and you'll see my code now, once I save it, returns 2, 4, 6, 8, 10. Now a couple of things to talk about here. Firstly, isn't that easy? That's so much easier than C. You don't have to worry about malloc and creating things. You can just create arrays, return arrays, don't worry about that. So this is what we mean by a high-level language. You don't have as much control or understanding of what the computer's doing, but you can write code much easier. The second thing to pay attention to is this triple equals here. Whenever you do double equals in JavaScript, it should be a triple equals. The reason for that is one of the less nice things about JavaScript, and I'll show you this very quickly. In JavaScript, watch this. If I say a equals 0 and b equals the string 0, if I say if a equals b, console log, they are the same. Else console log, not the same. If I run this, it will say they are the same. This is one of those weird things about JavaScript that kind of sucks. JavaScript with the double equals will compare if two values, if the value is the same. If you use a triple equals, it will compare if the type and the value is the same. So if I use a triple equals, that will say that. Now, you could argue this is useful, but most people don't argue that it's useful. And the way around this is if you just always use triple equals, it's the equivalent of what you would typically expect double equals to do. So that's kind of one of these like little pitfalls, is don't use double equals. Honestly, I've never actually seen a scenario where I've like used double equals and accidentally compared 0 to the string 0. That's kind of weird, but there are quite a few like edge cases that come from this. So that's why you see triple equals in some of the code, right? Yep. Cool. And then last example before our break. Actually, this will take like 5 minutes. So let's take a break and then come finish this one. So let's start up again in 6 minutes at 7:10. I'm pretty certain that we will definitely not run out of time tonight. We might even finish early if we're lucky. Yeah, we'll see how we go. We're not going to run over time. So anyway, take a 5-minute break. We'll probably start at like 7:11, and then keep going. See you soon. Hey, welcome back. Oops. Welcome back from the break. I'm sure that was riveting for you. I don't do much on the break. I just kind of sit here and stare at the wall for like 6 minutes. But let's finish off this arrays piece. So everything we've talked about with arrays and for loops so far has been very C-like. But one of the benefits is that because it's JavaScript, because it's a high-level language, we can do some more fun things with it. So if we actually look at this code example here, I want to show you a couple of other ways that we can loop through things. So firstly, I have my items array, letters A, B, C, D, E. I can use my old school array, my old school loop, which was, my let I is 0, I is less than items.length, I plus, and then, console.log items I, like this. That works fine. However, another way that I can do things is using this in loop, this for in loop. I don't remember what it's called, but let's just call it a for in loop. And how this works, it's a little bit tricky if you haven't seen these kinds of things before, but once you get it, you'll get it instantly, which is that when you say for const I in items, what it does is it loops over every element in items, and for each loop, it runs this code where I is the index of where it's up to. So for instance, you'll see here, if I go and put console log I is I, right? And let me get rid of the rest of the code for a second so it doesn't confuse you. When I run that, you'll see that it says I is 0A, I is 1B, I is 2C, I is 3D, I is 4E, like that. So it's a really useful way if you want to loop over an array and get each index at a time. The other way, which is extremely similar, is a for of loop. And a for of loop, I'm so sorry if this, I actually don't know what these are called. Probably should have looked that up. A for of loop will actually do the same thing, except every time it loops, instead of it being the index of that array element, it will be the value itself. So you'll see the second one actually prints these 5 out here, A, B, C, D, E. So if you're trying to loop over an array to get the indexes, you use for in. And if you're trying to loop over an array to get the values, you do for of. Now, Michael's asked a really interesting question here, which is, are you not initializing I to be 0 here? You don't need to initialize I. This is kind of really unrelated to normal for loops in the sense that we're not really, how would you put it? We're not really like setting I and then incrementing it. Like, it's not like we're actually incrementing I. It's actually just like JavaScript is just pulling the indexes one at a time. And I think that's really important because each time this loops, it's kind of like its own little bubble. It's kind of like this loop here is quite literally, like this one here is quite literally just the equivalent of, this loop up here. Yeah, like they are the same for all intents and purposes. They are pretty much the same. It does all that for you. Like it does all the I equals 0 and the less than and the I plus plus. It's just at some point the people who wrote the language were like, oh my god, everyone seems to be doing the same thing. Why don't we make their lives a little bit easier? So they did that. And then people took it further and they're like, well, everyone seems to be looping over the index just to print out the value, so why don't we just do this one, the for of loop? A great question from Falways. Does I have to be const? No. Though you'd be a monster if you... No, I'm just sorry. I like being dramatic. I doesn't have to be const, but I can't think of a good reason you'd ever want it to not be const. It would be really weird to modify that value. It would just be not very like good programming, but I'm sure there might be a scenario. So just make it const unless you have something I've never thought about. Yeah. That's kind of it. And the benefit of JavaScript, which we're about to get to with objects, is that you can also do some other cool things. Like if you want to check if something exists in an array, you don't have to write a for loop and go through every element. You can actually do something like this, where you take the array and you say items.include C. And I can actually put this in an if statement, which might make it clearer to you all, which is like, C is in items, like that. Else, C is not in items. So there's some other cool language features like this where you can actually easily check if something's in there. You don't need to do for loops or anything crazy. So this is what we mean by a higher level language. Campus Blue says it seems to work without declaring it. So Campus Blue has figured out that if they just do that, it still works, I'm guessing. Yep. You know what, Campus Blue? You kind of don't need any of this. You don't need this const. You don't need this let either. JavaScript will figure it out for you. That's bad code though. So again, JavaScript is very forgiving. It's like, items equals that array. I wonder what they could possibly be doing with that. They're probably declaring a variable, right? Yeah. So that's that. Don't do that though. Don't rely on that. You're a good person. Okay, so moving on. The last kind of major thing, we have a couple of examples at the end, but the last major kind of new topic in JavaScript, which gives us the intro, which gives you enough to do a couple weeks of work easily. And I hope it hasn't been that much. Like honestly, it's not that much different. There's just a few little knickknacks and differences, and you'll settle in very quickly. Is we want to talk about objects. Objects in JavaScript are mutable associative structures. So they're the struct-like thing. If you've used Python, you'd know them as dictionaries. If you've used C, you know something similar as structs. But they are essentially when you need a collection of items that are not ordered, they're not sequenced, but they are identified by their string description that we... Oh, there's a typo. Objects. Alright, that's kind of funny. They are useful when you need a string description just like structs, right? So objects, you kind of interact with them like this. Now, while I say they're like C-style structs, I think it's really important that you don't use your knowledge for C-style structs, because syntactically they are actually quite different. So firstly, I'm going to create an object in JavaScript here. That object is going to be called student. That student object here contains a few keys in it. And those keys are name, score, and rank. And those keys have values Emily, score 99, and rank 1. These keys can be anything. I can make up another key. I can call Daniel oofed. Right? I can add keys all over the place if I want to. This is essentially, just think of it like, it's like an array, but it's different in the sense that, an array is like const something equals array brackets and then things. This is like const object equals braces and then things. It's the same gist, but also very different. You'll see that if I console log that object, it will just print it out for me. It'll say, well, here's all the keys and values. They're not ordered. They don't have a sense of order. It's just a mishmash of things with values. Petrus has asked, are we able to set keys uninitialized? Yes, but you kind of would do it like this. You would say, bad 1531 students is undefined. This is kind of how you would uninitialize it, I guess. There's not really a notion of uninitialized in JavaScript, but that's how you'd kind of create it, but say that there's nothing there. Falway says, are you able to reassign the variables for a const object like you can for an array? Yes. It's exactly like an array in the sense that student points to an object. That object is just a box or a balloon or a boat. It doesn't really matter what you call it. It's a thing, and everything that happens inside that thing can kind of be changed. But student will always point to that box. Alex has asked another question, which is, what's the difference between objects and the associated container thing you were talking about earlier? Nothing. They are the same. They are identical. This is the JavaScript implementation of an associative container. Cool. Now, there's a few other points and great questions people are asking. Let me show you a little bit more, and then we'll loop back to those questions. So, how do I print out elements of that object? And the answer is a couple of ways, but one way you can do it is just by saying the object and then .name. Because just like C with structs, when you get a struct, you can get a property of a struct by going struct.property. So I can get some of those properties here like this. I can get Emily and 99 and 1. I can also set a property like this. I can change it. I can change the height from... Well, actually, this one isn't even changing it. This one is adding it. But let's change one too. Let's change Emily's rank to 2 from 1. And now let's print the updated object. So now the object has another property called height, and Emily's rank has gone from 1 to 2. So, you know, it's a data structure. It's a different type of data structure. It's not ordered. There aren't indexes. There are strings. You know, when I first learned these data structures, and I'm sure many of you are similar, is like, it's kind of arrays, except instead of each element having a number index, it just has a string. And they're not in an order. There's a lot of differences between a C-style struct and a JavaScript object. One of them being that, probably the main one just being that it's dynamic. In C, you kind of have to define the struct at compile time. You can't just kind of add properties to it, change its types. I can change score from a number to a string if I want to. You know, it's the Wild West in a lot of ways. So that's like a little bit of an intro to objects. Like structs, but a little bit more interesting. A really good question that was asked from Daniel is, why do I have a comma here? Because you wouldn't have this in C. This is something that you'll see a bit more in the course later, but in a lot of scripting languages like JavaScript, like Python, it's pretty common practice to put a comma after every single element, like when you're doing elements line by line. Because what it allows you to do is to kind of remove lines and stuff without breaking things. So like, because you know the problem is if you don't have a comma and then you like say remove this line, you then have to remove that comma. That's kind of annoying. So it's like a bit more common practice to just do this. And this allows you to kind of move lines around without having to worry about which one needs to not have the comma. So that's pretty common in a lot of languages. And it makes your life a lot easier. And the compilers are smart enough to just like not worry about what's what. You know, they'll be like, yeah, comma at the end. That's not necessary. We'll just ignore it. And to Neil's question, we don't have to use the stab in JavaScript, right? Yeah, exactly. There is no stab in JavaScript. That's pretty normal. Okay, so that's like a really basic example with objects, but let's look at a couple more things with objects. So when it comes to objects, there are different ways that you can define them. You can do what we did in our code example just before, where you kind of say an object, you say, you know, a variable is equal to an object, and then you define it all right there. Or alternatively, you could just create an empty object like this. And then you could just define everything like this, student. You could just create an empty object, and then I could just go through and I could define everything like student.name equals that. And there you go. There's your there's your code. You could do that too. These are both the same thing. They'll give you the exact same output. So you can create it all up front. You can create it as you go. You can do a mix of both if you want. That's kind of what we did in our first example, where we like set some up here and then set some down there. So that's all totally fine. And then similarly, and this one is really important, JavaScript has two different ways that you can access properties of a struct, right? And this is important because it kind of can do C style and Python style, for those who know Python, because it seems like a lot of people here know Python. You can kind of do both. The way we've just done it in the lectures is C style, where I say dot, you know, an object dot property is equal to something. But you can actually use this other method, which is it's also like array style in a way, where like I put prop here in the brackets like this. So for instance, if I wanted to, and this is only after the creation, when you create when you create objects, they always look like that. But after you create them, you can actually do something like this. So this is also equally valid. I just wouldn't recommend mixing them. I don't know if there's a better or worse one, but I just wouldn't recommend mixing them. So these two things are exactly the same. The one difference, right, is that with the square bracket method, you can actually like do dynamic lookups. And what I mean by that is like I can say here const key equals height like this. And then in here I can say key. So key is like dynamic now. So I can actually write code that might, if I change this from height to width, you'll notice that the object will change. Keep an eye on height here. Changes to width. So this is like, this kind of square bracket is very useful if you kind of have code that let me give you a really quick code example. Let's say I have some names, right? I got Hayden, I got Neil, and I got Daniel. And let's say I want to go create an object where, or an even better example. Let's imagine that I have an array of a whole bunch of name instances, right? Like this. And let's say I've got Daniel 3 times and Neil 4 times and Hayden a few times. If I want to write some code that counts these, I could go and say create an empty object. I could then loop through the names, const name of names, like this. And then I could say counter name equals 1. Now what this will do is every single loop through every single name, it will set a particular object's key, and that key is one of the names to be 1. And then if I print out counter, you know, what do you think you'll get? You know, have a think for a second. What will this output? Pause the video if you're one of those watch at home people. What will this output, right? What it will output is it will output Hayden 1, Neil 1, Daniel 1. And that's because the other thing about objects is it's not like an array where you're just kind of pushing new things all the time, but you can only ever set a key to be something. So when I say, you know, Hayden is 1, and then I say Hayden is 1, and then I say Hayden is 1, 3 loops in a row, it's just going to kind of override it. But let's say I want to actually count them. So now what I'll say is, you know what? Hayden plus equals 1. Let's see what this does now. What the hell is nan? So nan in JavaScript is a bit of a weird thing. Nan is what happens when you upset JavaScript and you tell it to do something that confuses the hell out of it. A really good example is if I try and console log 3.3 plus he, I will usually get, that that turned 3.3 into a string, and then it I don't even know. What's an example? How would I get not a number? Is it like he times 2? Or is that, I don't know. Someone will know something. Yeah, you go. If you try and multiply a string by 2, JavaScript's just like, I don't know what the hell that is, right? It's just like, well, this is clearly not a number. That's the most I'm telling you. The reason this happens is because if you think about it, if I console log the object here, I'm doing a few extra examples because we're moving through this pretty quickly. You'll see here that the first time I loop through it, the object is empty. And therefore, when I tell it, hey, counter name plus equals 1, which is the equivalent of saying counter name is equal to counter name plus 1, what is counter name, right? Well, it's undefined because it literally doesn't exist. See how this object here is empty? It's just completely empty. See, it's undefined. And what do you think happens when you add undefined? Like, watch this. What is undefined plus 1 in JavaScript? Not a number. So to get around that, what we do instead is we first need to set that key in. And what I mean by that is you can actually check. You can actually say, you know what? If the key name is in counter, this is something to do with objects, I can actually say, you know, counter name plus equals 1. However, if it's not in there, then let's just set it to be 1 to start. And now we'll have something a bit more interesting. So when I say is name in counter, we saw this whole in thing with arrays. And the in thing with arrays was interesting because it did a different thing to what we're doing here. But here what we're actually doing is say, you know what, is the key name, is Hayden here, is that one of the keys in the object? And if the answer is yes, then I go, great. It's already in there. I can just increment it because it exists. It's not undefined. But if it's not in there, I could just go and set it to be 1. I'm sure there's a smart language out there that could figure this out. But if you think about it, you don't really want it to figure it out. Like, how can it assume what the default value should be? Most often, to be honest, you would actually probably write this a little bit differently. I've written it here a little bit easier for you, but if you were writing this yourself, you'd probably more likely write it like this. You'd probably say, is name not in there? And if name's not in there, you would initialize it to 0, and then you would just increment it anyway. That's kind of the slightly more concise way that you'd probably write something like that. So this is like, just check that it's not undefined. If it's undefined, set it to 0. And then increment it because we're counting stuff. This is a very kind of classic frequency counting problem you'll see in programming. That's kind of how you'd go about that in JavaScript. That was quite a tangent. But you know, we've talked about objects. We've got a couple more object slides, and then we're done with the start of objects, and then we look at some more interesting examples. So here, another interesting thing about JavaScript is that it has a couple of built-in functions that get you things from objects, because objects are a little bit weird to work with. Arrays are much simpler. Arrays, you probably just, yeah, I get arrays. Objects are a bit more funky. So here I've got an object called user data. And I'll come back to Terrence's question. I've got this object called user data with a name, an age, and a height. Sometimes we want certain things from our object. A really good example is, what if you want a list of all the keys? What if I want all the keys? I want name, age, and height. Well, if you actually pass the object into the function object.keys, this is built into JavaScript, it will actually turn your keys into an array. So what this does is this actually got all my keys and turned it into an array. So this keys is an array now. That could be useful sometimes. Sometimes you might want to just print out all the keys. Sometimes you might want to, I don't know. You don't use that as much these days, but we'll talk about that later. Another thing you can do is dot entries. And if you do dot entries, that will give you all of the values in a list. Oh, sorry. Dot entries gives you, let me do that one. I don't know why that's in that order. I should really swap that around. Let me make another note of that. My endless notes. What slide was that on? 15.4. I am getting tired. So, yep, if I do dot values, I will get the values. I'll get Sally 18 and 187. To be honest, that one's kind of useless. I've never really used that before. Entries, though, kind of gives you both. So entries gives you an array of mini arrays. And those mini arrays contain the key and the value. The key and the value, the key and the value. So sometimes that's useful. Sometimes you might want to... Because, sure, you can just print this. You can just say console log user data. You can do that. But what if you want to print it a bit nicer? Right? I could say, you know what, for const entry of object.entries user data, console.log key entry 0 equals entry 1. Because remember, dot entries returned a list, right? A list of 3 items, and I'm looping through those 3 items, and entry is that inner list here with 2 items. So I'm going to grab the first and the second part. And now I can print those out quite easily. This goes really deep, and this is what I meant at the start of the lecture. Like in C, you only you can just do a handful of things. It's a really simple language. I think it's a great language to start learning programming with, but there is kind of just there'll just always be a new thing you don't know. There's a ton of things I haven't mentioned tonight. You don't need to know them. You don't need to know this. This is just here to kind of show you that there's some breadth to it. It's just to demonstrate that there is more that you probably don't know too. So that is a little bit more on objects. You can do some other fun things with it. And then the last slide here is looping through objects. Now, we already touched on this in our little Frankenstein example that we did. But I've got my user data object here, and you can see that I can loop through an object. Though this is the funny thing. With objects, when you loop through them, it loops by default through the keys. And what I mean by that is that looping through user data is I don't know if keys is a thing. This is pretty much identical to just doing object.keys user data. So those two things are identical. JavaScript's just smart enough to be like, oh, you want to loop through this object? Well, here, let me give you the keys. You can see that it gives you the keys there. So if you want to print out things from a JavaScript object, typically, honestly, what I would do is just this. I'd just be like, yep, for key, const key in user data. And sometimes it's easy. Sometimes I would probably just if I was debugging this, I would just quite literally do this. I'd be like, user data key. Which looks a bit weird, but it kind of makes sense, right? Because if you're looping over keys, to get the value at a particular key, you just get that object and say, give me the value at that key. Done. Easy. And then what we see at the bottom here is exactly what we did in that example before, where we actually just checked if a key exists in an object. And we did that just by saying, if this key is in that object, have some key. So Daniel's asked a question. So is an array just an object where its keys are a numerical index? No. Arrays are still implemented as arrays. They probably are contiguous, and they are structured in a certain way. They would perform differently. The fundamental structures in JavaScript and C are relatively similar. It's just JavaScript kind of combines a couple. So again, in JavaScript, you don't really have linked lists. But I just don't know. How a lot of these languages' data structures are implemented are very complex sometimes. Sometimes they won't literally be, but sometimes they'll be arrays, but with some other performance benefits. And you can kind of go Google that. I know a lot about that in C++. I don't know much about it in JavaScript, but it can be very, very interesting. I want to loop back to Terrence's question. I kind of missed it before. So if we just loop for a second back to a previous example, Terrence asked me this is what we had before. Terrence says, can you check if name is undefined? Good question. Name is not going to be undefined, but counter name is sometimes undefined. So this should also work the same. I don't know if that's better or worse. I don't know if it matters much. if anyone's a C programmer, this should kind of scare you, because if you're if you're kind of used to trying to get like indexes or properties of things that don't exist, usually this is where you get into a seg fault. So your programmer brain might trip up a bit. JavaScript's smart enough to be like, if you ask for a particular value at a key that doesn't exist, i.e. if you ask for something at an address that doesn't exist, JavaScript just says undefined. I don't know. I don't know. I don't know if one's preferred or not. I haven't ever read into that. I don't know if there are limitations of this. I don't know if there are times this breaks down. I'd probably recommend doing it this way, because I think this is a little bit clearer, that you're actually, like, it reads as checking if a key exists as opposed to checking if the value at a key is undefined. Because you got to remember, actually, I think I understand. So I think a tricky thing with what this is this is also, like, I'll show you what I mean here, right? It's like, this is undefined because there's nothing at that key. I'll give you an example. So it's like, let me get rid of this for a second. I'll try not to waste too much time. It's fun that we have a little bit of time tonight so we can learn a bit about the language. But let's say I have a counter. Let's say, you know, if counter Hayden equals undefined, right? Console log not there. Why this is tricky is this is not distinguishable from this. As in, this if statement will pick up on both of these scenarios. Because the key existing and the value at that key being undefined is the same as the key not existing. So that's probably why it's better to do this. Because this one is more explicitly checking if the key exists. Because this won't return, but this will return. It's an interesting question. I've never thought about that before. Okay, that's the code part of objects, but to touch a bit more on JavaScript, in JavaScript everything is an object. Literally everything. Now, you don't need to get too philosophical about it, but everything in Java is an object. And what that means is that, you know how in C you have structs, and structs are like a box? Everything in C is a box. Strings, ints, arrays, objects, everything's a box. This does not make JavaScript an object-oriented programming language. It just makes it a language with objects. And the reason objects are interesting is because this explains the dot thing. And this is why, in examples you've seen, when it comes to arrays and when it comes to objects, you've seen us use the dot syntax. You've seen us use dot length. Right? You've seen us do something like this. And that's because in C, an array is literally a pointer to a block of memory. That's it. Like, an array is quite literally just a pointer. So, you know, you got C, you got your little array here, points to a block of memory. That's all it is. Your array is just a pointer. But in JavaScript, if you have like an array, if you have something like const array and it equals something, that list it's pointing to, right? It's not just a block of memory like this. It also has some extra data inside the box. It's also got a few other things like, maybe the length and a few other properties. So you can kind of actually imagine that in JavaScript, an object, like it's very, okay, this is where it gets really tricky. When I say that everything is an object in JavaScript, don't get that too confused with us just learning about objects. What we really mean by that is that an array is not just blocks of memory. An array is actually a box of stuff that includes the block of memory, it includes the length, it includes a few other things. And that's why with your code, you can actually say students.length. Because students is not just an array or an object, it's actually a... the word object's thrown around too much here. I haven't thought about this too heavily, but the point is that students itself is not just a bunch of numbers. It contains some other things inside the box, and that's what this dot is. Because just like structs, right? Like if you think about a struct as a box with some properties in it, In JavaScript, you know, an array is a box with the list in it and some properties. An object is a box with some keys and values and some other properties. And that's why we can do things like length here. The one subtle thing about these languages like JavaScript, though, is that these boxes don't just have properties, they also have functions. That's what we had back here way early on when we learned about arrays. We had evens.push. We could push to the evens array because inside that array box, yeah, James says it's got metadata. Yeah, it's kind of got metadata. It's got stuff in it. You know, it's not just a list of numbers. It's a box of stuff, and the list of numbers is in that box. So I can do push here because push is just a function that exists inside that box. And this is honestly something that I might be making sound harder than it is. It's actually very intuitive. Like, if you didn't notice this much before, that's because it's so intuitive that you didn't even have to think about what it is. And you'll see that quite a lot working with the language. You can combine you can combine arrays and objects in JavaScript, and we've kind of done that in this example here. I've gone and created 3 students, 3 objects, with Hayden, Nick, Emily, and different scores. And then I've gone and created a students variable on line 4 that is an array of those 3 items. So now what happens is that, as far as my code is concerned, I've got this students array here. And that students array is an array of 3 items. And each of those items is like an object. Object 1, object 2, object 3. And each of these objects has those 2 properties in them, like this. That's how it's structured, right? Really easy. So now I've got my list of objects, and I have 2 approaches here of how I can use them or print them, right? The first one is I can say, well, the number of students is students.length, and then I create a for loop. And that for loop is, you know, let I equals 0, I is less than num students, I++, very C style. I can get a particular student because remember, if students is my array and I is the index, by saying students index, I can actually go and say, oh, I want this object here. So student here is the first object. And then I can check, is the student score, because remember, score is a property of that object. That's what this is. I can check if that score is greater or equal to 85. And if it is, I can console log that the student's name, their name, got an HD. And then this is a little bit more of a JavaScript way to go about it, where I use the for of loop to loop through it. The for of loop means I don't need this kind of stuff. I can just say, yep, go through my array of 3 objects, and each time I loop, student is one of those objects, and then just check if the student's score is greater than 85, and if it is, they got an HD. Really, really simple. So you can write really concise code that looks something like this, where someone says, oh, can you tell me which students got an HD? It's like, yep, done. Just like that, print it all out. So that's just me playing around a little bit with the code. These are kind of not meant to be examples that I would expect everyone to be like very comfortable with tonight, because for many of you it's just the first time you've thought about this, but these are just kind of here at the end of the lecture. Oops, I think I just jumped straight to the hardest one, my bad. Oh, we had a few here, okay. Well, we started with the hardest one, so if you got that, then the next 5 minutes is going to be really straightforward. But just to kind of start at the top really quickly, this example was meant to show you that you can create arrays of objects. So in this case here, I have an array of 2 things, and each of those things is an object, and each object has 3 properties in it, 3 keys and values. And if you run that, you'll see that I don't actually think this code works. Oh, no, it does. Oh, no, I don't think this code works. Very weird. I think this code's a bit busted because you shouldn't really be calling object.keys on a list, on an array. So that's likely just a funny typo. Let me add a note of that. I mean, you know, but it doesn't really matter. The point of this slide was to show you that you can have arrays of objects, and similarly you can have objects of arrays. You can kind of combine these. You can have objects of objects of objects. You can have objects of arrays of objects. Daniel says, What's stopping you from adding another key to an object in your array? Nothing. You could just go and add it. We could do that right now. If we just try and print out user data, it'll look like that. And nothing stops us going user data 0 width equals 7. We could just do that and it would add it in to just one of the objects. So we can go and manipulate it really easily like that. The next example here was just showing how we can maybe manipulate this a bit more, or more specifically just like read from it. So if I was to say wanted to loop through this user data array, I can loop through both items and then I can say, well, user data I gets me the object, and then I can get the name, I can get the age, I can get the height like this. And actually display it like this if I'd like to. This is just more ways of dealing with it. Or I could do some more loops, and then we get on to our last example, which we started with. And this one here is doing what we learned before, where we say, oh, here's my object of objects. This one's a bit more interesting, actually. And I think this one's worth paying attention to because objects are really, really, really useful. Like I would use objects a lot more than I would use arrays in these languages. So here I've got an object of objects, and this object contains two keys, Sally and Bob, and Sally is an object of just age and height, and Bob is an object of just age and height. So when I say for const key and user data, what I'm doing there is I'm actually looping through user data, right? And I am getting the key in each instance. And that means that the first time I loop, the key is going to be Sally. The second time I loop, the key is going to be Bob. So I console log that key, and you'll see if I comment out a couple lines of code that, you know, Sally's properties are, Bob's properties are. And then what I can do is to actually get a bit more info. I can say, well, user data key, user data Sally, is the actual object here, right? User data Sally gets me that. So I can loop through the keys of that one and then print out that that key is that value. So this is kind of how I could do like a... We talk a lot, you know, in C about 2D arrays, whereas here we're really dealing with, you know, 2D objects, if you want to think about it like that. There's a lot, you know, I mean, these are quite involved examples, but the point of this lecture was to just kind of throw it all at you so you can go and look at it anytime. All the code's here, it's easy to look at, it's easy to play with. But that's the basics of JavaScript. There's a couple other things we learn in the course about importing and functions and stuff, but that's the language. Thankfully, the language is quite, you know, because you've done C, a lot of the language should be very manageable. So this is enough. Everything we've done tonight is enough to get you through Labs 1 and Labs 2. Everything we've done for the last two lectures. We will learn a lot more about JavaScript, to answer your question. Yep, there's a lot more about the language. If you know more about the language, there's a good chance that we cover it more. But yeah, so the point of today, just to recap, because we're wrapping up, is to give you all the knowledge you need for week 1 and week 2. So that's why week 1 feels a little bit heavier, because we kind of have to get in and get ready. So that means that you can do all of Tut 1, Lab 1, all of Tut 2 and Lab 2 with just the knowledge from today and yesterday. And then when we start learning things next week, that's used for week 3 and so forth, right? So that's what kind of happens. But in essence, it's a very similar language to C. We covered that really quickly. And you just kind of need to think about arrays and objects. That's all we talked about tonight. A couple of syntactic differences and then arrays and objects. To the Meridians question, when are labs due each week? Labs are due on the Monday after the week we give them to you in. So week 1's lab is due Monday sometime. It's written in the lab. I can't remember. It's always due on the following Monday. Cool. Well, evening lectures are no doubt a bit tiring. I know I've said it 3 times already, but just like last night's Git lecture, I want to stress tonight is about introducing you to concepts. Getting comfortable with them takes weeks. And that's why we have a course that is 10 weeks long. So here's the introduction tonight. Let's go and enjoy putting them to practice. Let's go and enjoy having fun with them. Your tutors will help you out. That's all from me tonight. I will email you all on Friday. I like to email you all Friday late evening with some updates. So you'll get some updates from me on Friday evening. And then I'll see you next Monday. But congratulations for getting through the first little hump of the course. We're going to have a lot of fun. Keep going. And post on the forum if you need anything. And good luck for those going to your first tutes this week. I know some of you would have already been. If you haven't, your tutors are really excited to see you. So go enjoy that. Anyway, that's all from me. Have a great evening. Don't be too cold if you're in Sydney. If you're overseas and coming here soon, we'll be welcoming you openly. Look after yourselves. Get sleep, drink water, all of that. It's important. Oh, feedback. Oh, yes. Thank you so much. Feedback QR code. That way. Yeah. So fill that in. Thank you. Great evening, everyone.